Okay, we're going to do some section 1.4 review problems. We're going to start with the problem square root of 2x plus 3 minus 1 equals 2x. Now your first step here is going to be to isolate the radical, add 1 to both sides, then raise both sides to a power that will eliminate the radical. In this case, you would square both sides. So why don't you do that and then see if you can solve the resulting equation. So after you isolate the square root, you square both sides. The right side, remember to FOIL it out. 2x plus 1 times 2x plus 1. Now if you've done all that, you should get to the point 2x plus 3 equals 4x squared plus 4x plus 1. Now you should recognize that's a quadratic equation. We use the methods that we learned in 1.3, either factor it or quadratic formula. And generally, unless it's in the form where you extract square roots, you get all the terms on one side and go from there. So that's what you should do, and then solve it. So we get all the terms on one side. Then we could solve with the quadratic formula or factor it. I'm going to factor it. And I start by factoring a 2 out, a common factor of 2. Then factor some more, 2 times 2x minus 1 times x plus 1. By the zero product rule, we let each factor equal 0. So we get 2x equal 1, x equal 1/2. And then our other factor set to 0 gives us x equal -1. And we might say we're done, but no, we're not done. For these square root equations, we always have to check for extra answers by plugging in the answers into our original equation. So we plug those numbers in, x equal 1/2. When we plug it in, we get the square root of 4 minus 1 equals 1. 2 minus 1 equals 1. That checks out. So 1/2 is an answer. When we plug -1 in, however, we get -2 plus 3 minus 1 equal -2. -2 plus 3 is 1. The square root of 1 is 1. 1 minus 1 is 0. That does not equal -2, so we throw out the answer of -1. You always have to check these square root equations. Sometimes both answers work, sometimes one answer works, sometimes neither answer works, and it's hard to predict. Okay, the next type of equation we're going to look at are the rational expression equations. So here we have these algebraic fractions in an equation with x's in the denominator. We don't want those x's in the denominator. So the way to get rid of them is to multiply both sides by the least common denominator. And in this case, the least common denominator is going to be x plus 2 times x minus 1. Because 2 is just 2 over 1. So multiply both sides, all the terms, by that least common denominator and simplify it and go from there. Okay, so just to get you off on the right start here, we do that multiplication. And we see that the denominators all cancel away on the left side. So you're left with the equation x minus 1, and it should be plus in between there, plus x plus 2 times, don't forget the 3 that's left there. And on the right side, you have 2 times x plus 2 times x minus 1. So that's our new equation without the fractions in it anymore. And now we have to solve that by multiplying everything out and simplifying and then solving. So now when we do all of these steps, do the canceling, get our new equation, multiply it all out, and then get to x minus 1 plus 3x plus 6 equals, and on the right side, 2x squared plus 2x minus 4, and then move all the terms to one side, we should end up with the equation 0 equal 2x squared minus 2x minus 9. That's your simplified quadratic equation. You're not done yet. You have to solve that. And that's easiest solved with the quadratic formula. So you plug all of that stuff, the coefficients, into the quadratic formula, simplify, and you get 2 plus or minus the square root of 76 over 4. Now, if you're doing a Webassign problem, you'll find that this doesn't match their answer because they simplified that radical. I don't know if they'll mark it wrong or not, but I know it won't match their answer because we can simplify square root of 76. It's the square root of 4 times the square root of 19. Then that square root of 4 factors or turns into 2. We can factor a 2 out of the numerator and then cancel the 2 with the 4, leaving 2 in the denominator. So the simplified answer is 1 plus or minus square root of 19 over 2. Okay, the next type of equation we're going to look at are factorable polynomial equations. And to solve them by factoring, we have to get all the terms on one side. So make it equal to 0. This one's already equal to 0. And then we factor it. And the reason it's solvable because there's going to be a greatest common factor. In this case, x. X factors out of all the terms. And that leaves you with x times a quadratic. X times 3x squared plus 11x minus 4. Now, we can either factor the quadratic or solve it with the quadratic formula. And then that's fine if we have to use the formula. We could try factoring this, however, and using the grouping method or possibilities. I kind of like, I like the possibilities method. Numbers we have to put in here are either 2 and 2 or 4 and 1. And we can see we can get the 11 by taking 12 minus 1. And we achieve that by putting the plus 4 to multiply by the 3x, the minus 1 to multiply by the x. So now applying the zero product rule, we let each factor equal 0. In this case, we have x equals 0, or 3x minus 1 equals 0, or x plus 4 equals 0. X equals 0 is also already solved. Now we solve 3x minus 1 equals 0. Add 1 to both sides. X is 1/3. And then x plus 4 equals 0. X is -4. So we have 3 answers. Don't forget that third answer of x equals 0 because it is a solution to this equation. Next, we're going to look at an equation that's very similar to what we just did. It's called the quadratic form equation. And the type we're going to look at are where you have an x to the 4th, you have an x squared, and then you have a constant term in the equation. Now, it turns out these equations are solved just like quadratics. You can either use the quadratic formula and substitution, or you can factor them if possible. In this case, this equation factors. See if you can factor this and solve it. So if it factors like the quadratic, you want to find two numbers that multiply to -8 but add up to -2. Those two numbers are -4 and 2. So the factorization, instead of x minus 4, it's x squared minus 4 times x squared plus 2. And we've got it factored. It works out. You can FOIL it out and check it. And then let each factor equal 0. X squared minus 4 is 0. X squared plus 2 equals 0. We get x squared equal 4. X squared equal -2. Extract square roots. X equal plus or minus the square root of 4. X equal plus or minus the square root of -2. And plus or minus square root of 4 is just plus or minus 2. We write the square root of -2 as plus or minus I square roots of 2. Remember that stuff from P6. So there's our 4 answers. And that's the easiest way to solve these if you can factor them. Another way to solve these, and probably Webassign is showing you this method, and it is a method you want to know, because if that does not factor, you'll want to use this method. We let u equal x squared, then u squared becomes x to the fourth, and then we substitute out. We get this new equation in terms of u. Now, if that didn't factor, we could use the quadratic formula to solve for u. Maybe we'll do that just to demonstrate this method. So we plug into the quadratic formula, and we get u equals 2 plus or minus the square root of 36, which is 2 plus 6 over 2, or 8 over 2, 4. And also 2 minus 6 over 2, negative 4 over 2 is negative 2. That's not our answers. That's u. That equals x squared. Those answers equal x squared. So to get x, we extract square roots. X is plus or minus the square root of 4, which is plus or minus 2. And then also x is plus or minus square root of negative 2, which is plus or minus I square roots of 2. So there's our answers we got before. If we had to use the quadratic formula, that would have worked. We could have also factored this u equation and gotten those two answers for u. But I'm just showing what you would do in case you couldn't factor and had to use the quadratic formula. Now we're going to look at a few equations with rational exponents. We start with the equation 2x to the 2/3 minus 2 equals 6. Now if you read the book or look at my notes, we see that the procedure here is to first isolate that x to the 2/3 power. So we start by doing that. So we add 2 to both sides and then divide both sides by 2, and we have x to the 2/3 equal 4. Now the way to solve for x is to raise both sides to the reciprocal power. So we raise both sides to the 3/2 power. On the left, the exponents cancel each other. We're left with plain old x. On the right, we have x to the 4, or 4 to the 3/2. However, we need a plus or minus here because this numerator exponent was 2, an even value. I'll show you in a second why that's the case. I go through that in the notes as well. So we have plus or minus the square root of 4 cubed, which is plus or minus 2 cubed, or plus or minus 8 is our answer. To show you why we need that plus or minus, let's look at the radical form of that equation, x to the 2/3 equal 4. That's really the same as the cube root of x squared equal 4. And we can solve that by cubing both sides, which eliminates the cube root. That gives us x squared equals 4 cubed, or x squared equals 64. Well, we solve that by extracting square roots, but remember, we get the plus or minus when we extract square roots. So we end up with x equal plus or minus the square root of 64, which is plus or minus 8, our answers. Okay, let's try another one. 2x to the 3/4 power minus 39 equals 15. Here, the 3/4 has an odd numerator of 3. We won't need the plus or minus, but otherwise we solve it the same way. Isolate that x and raise both sides to the reciprocal power. So try and do that. So here we add 39 to both sides, divide both sides by 2, and we have x to the 3/4 equal 27. Simplified equation. Raise both sides to the 4/3 power, and we get x equals 27 to the 4/3, which is the cube root of 27 raised to the 4th. Cube root of 27 is 3. 3 to the 4th is 81. And here off to the side, I show why we don't need the plus or minus. X to the 3/4 equal 27 is the same as the 4th root of x cubed. We could solve that by taking the 4th power of both sides, then taking the cube root of both sides. And we don't use the plus or minus when we use the cube root of both sides, because x cubed is positive if x is positive, and it's negative if x is negative. You don't have two opposite x's squaring out to the same value. So no plus or minus here. Always look at that numerator. Is it even or odd? If it's odd, no plus or minus. If it's even, there is a plus or minus. Okay, the last problem I'm going to look at here is one out of Webassign. Solve the equation 3 over x plus 2 minus 1 equal 3x plus 16 over 2. Now this is like one of the previous problems that we did with the rational equations. We wanted to get rid of those fractions. And we did that by multiplying both sides by the least common denominator. In this case, the least common denominator has an x plus 2, but it also has 2. So you multiply all the terms on both sides by that least common denominator to get rid of these fractions and go from there. So try and do that. Get to that step where we have an equation without fractions. Okay, now we kind of go through the long journey of getting this thing all shaped up into one equation. When you multiply through each and every term by that 2 times 2x, or 2 times x plus 2, in the first fraction the x plus 2's cancel, leaving 3 times 2, or 3 times 2, 6. The x plus 2's are gone. We have minus 2x minus 4. On the right side, the 2's cancel, leaving x plus 2 times 3x plus 16. We keep simplifying. 6 minus 4 is 2. 2 minus 2x equals. Then on the right side, we FOIL it all out. Subtract 2 and add 2x to both sides. And we end up with the simplified equation 0 equal 3x squared plus 24x plus 30. Now we work with that equation. And as I've been saying all along, since section P4, factor the greatest common factor out every time if you can. In this case, we can factor a 3 out. So we have 3 times the quantity x squared plus 8x plus 10. And now it almost looks like it'll factor, but it doesn't. It doesn't factor. So you have to then use the quadratic formula to solve this. So you plug coefficients into the quadratic formula. You get negative 8 plus or minus the square root of 64 minus 40, or negative 8 plus or minus the square root of 24 over 2. That's the correct answer, but that's not the one you'll have in Webassign, because we can simplify this. And see if you can simplify this to the simplified answer. So we simplify the square root of 24 as the square root of 4 times square root of 6, which is 2 square roots of 6. We can factor a 2 out of the numerator and denominator. Those 2's then cancel. And then our final answer, simplified, is negative 4 plus or minus square root of 6. That's what they have in Webassign. So yeah, there's a lot of work to this problem. And that's it for the review for this section. There was a lot to this section, but we got through it. So we'll see you in class or see you in discussions.